Okay, so we are going to finish up section 8-1 on arc length that we started in class on Monday. So we went over how we derived the arc length formula. And we're just going to do two examples here utilizing that arc length formula. So the first example asks us to find the length of the semi-cubical parabola y squared is equal to x cubed between the point 1, 1 and the 0.48. So there are two ways that we can set this up, and only one way that we're going to be able to solve this by hand. So let's go ahead and set arc length up with respect to x, which we're going to compute by hand, and then we'll set up arc length with respect to y, which we can set up, but given what we know about integration, we're going to need to use our calculator to evaluate the integral. Okay, so just so that you guys recall, arc length with respect to x is going to be our integral, where the limits of integration are written in terms of x values. So if we look at the 2 points that we are given, the x values of those 2 points are 1 and 4 respectively. So those are going to be the limits of integration. And then we are going to integrate the square root of 1 plus dy over dx, quantity squared. And we're going to integrate that with respect to x. So what I need to do here is I need to get y written as a function of x. So if we take the function y squared is equal to x cubed, if we take that equation and attempt to isolate y, we can take the square root of both sides. So when we do that on the left-hand side, we get the absolute value of y. The right-hand side, the square root of x cubed, we can rewrite that as x raised to the 3/2 power, which is going to make y equal to plus or minus x raised to the 3/2 power. Now, when we look at those two functions for y, there's only one function that works so that the graph contains the 2 points in the problem, 1, 1 and 4, 8, and that is the function positive x raised to the 3/2 power. Okay, so that's going to be the function that we are working with, x raised to the 3/2 power, and then we are going to go ahead and take the derivative of that. So dy over dx is going to be 3/2 x raised to the 1/2 power. Okay, so we're going to go ahead and plug that now into our arc length formula. So we get arc length in terms of the variable x is the integral from 1 to 4 of the square root of 1 plus 3/2 x raised to the 1/2 power quantity squared, which we are integrating with respect to x. And then I can go ahead and simplify the argument of the radical. So this is going to become the integral from 1 to 4 of 1 plus. I'm going to square each factor in the parentheses. So 3 squared is 9. 2 squared in our denominator is 4. And x to the 1/2 power quantity squared is going to be x. So we get the square root of 1 plus 9/4 x, which we are integrating with respect to x. Now, if we're going to integrate this, we have to do a u substitution to integrate. So I'm going to let u equal the argument of the function. So the argument of the radical, 1 plus 9/4 times x. And when we differentiate that, du is going to be equal to 9/4 dx, which makes dx equal to 4/9 du. Okay, so arc length then as a function of x. So my goal when doing u substitution is I want to get my integral, all parts of my integral, so the limits of integration, the integrand, and then what we are integrating with respect to, all written in terms of the variable u. Okay, so if I plug the two limits of integration in the place of x in my u equation, we get 1 plus 9/4 times 4 for the upper limit, which is 1 plus 9, which is 10. And then when I plug 1 in the place of x in that u equation, we get 1 plus 9 over 4, which is 13 over 4. Okay, and then I'm going to wind up integrating the square root of u. We're going to replace dx with 4/9 du. Okay, so we can go ahead and integrate this now. So arc length with respect to x, I can pull 4/9 out front. The antiderivative of rad u, or u to the 1/2 power, is going to be u to the 3/2 divided by 3/2, which is the same thing as multiplying by 2/3. And then we're going to add, or sorry, we're not adding c because we have a definite integral. We're going to evaluate that at 10 and 13 over 4. Okay, so we get arc length in terms of x as 8 over 27. And then we're going to have plugging 10 in the place of u. We're going to have the square root of 10 cubed, which is 10 rad 10, minus, and then when I plug 13 over 4 in the place of u, that's the square root of 13 over 4, which is like rad 13 over 2. And then when I cube that, that's going to become 13 rad 13 all over 8. Oops. All over 8. Okay, and that right there is arc length with respect to the variable x. Now we can also set up an integral to compute arc length with respect to y. Okay, so if we want to set up an integral to calculate arc length with respect to y, that is going to be equal to, so our limits of integration need to be written in terms of y values. So if we look at the y values that contain the two endpoints of that semi-cubical parabola, the first y coordinate, or the smallest y coordinate of our endpoint, is 1. The largest y coordinate of our endpoint is 8. And then we're going to take the square root of 1 plus dx over dy, quantity squared, and then we're going to integrate that with respect to y. Okay, so we're going to take our same equation. I'll do it up above here. Okay, so y squared is equal to x cubed. And then we're going to go ahead and solve this equation here for x. So we're going to take the cube root of both sides. So when we do that, we get the cube root of x cubed, which is x, equal to the cube root of y squared, which is y, raised to the 2/3 power. And then the derivative of x with respect to y is going to be 2/3 y raised to the negative 1/3 power. Okay, so we're just going to go ahead and plug that in for dx over dy in our arc length formula. So arc length with respect to y is the integral from 1 to 8 of the square root of 1 plus 2/3 y to the negative 1/3 power, quantity squared, which we're integrating with respect to y. And then when we go ahead and square all of the factors in the parenthesis, we get the integral from 1 to 8 of rad 1 plus 2 squared is 4, 3 squared is 9, y to the negative 1/3 power squared is y to the negative 2/3 power, which we are integrating with respect to y. Okay, and we don't have the integration techniques to be able to evaluate that by hand, so you need to use your calculator to evaluate that integral. Okay, so let's move on to our last example. So the last example asks us to set up an integral that calculates the length of the arc of the hyperbola xy is equal to 1 from the point 1, 1 to the point 2, 1/2. Okay, so go ahead and pause the video while you guys work on that. And then whenever you finish, you can unpause and we'll work it through together. Okay. So again, just like in the previous example, we have the ability to set up our arc length integral with respect to x or with respect to y. I'm going to go ahead and do so with respect to x. So I'm going to go ahead and take this equation, xy is equal to 1. I'm going to solve it for y. So we get y equal to 1 over x. And then the derivative of y with respect to x is going to become negative 1 over x squared. Okay, so we're just going to go ahead and plug that into our arc length formula. So arc length with respect to x is going to be equal to the integral of, we want both of our limits of integration to be in terms of x values. So the x coordinate of the endpoints of the hyperbola that we're trying to calculate arc length for are 1 and 2 respectively. And then we're going to take the square root of 1 plus the derivative dy over dx, which is negative 1 over x squared, quantity squared, which we're integrating with respect to x. And then this is going to become the integral from 1 to 2 of the square root of 1 plus negative 1 over x squared. Whenever we square that, becomes 1 over x raised to the 4th power, which we are integrating with respect to x. And you can do some stuff to like algebraically manipulate that, but that's in a good enough spot for us for the setup for that integral to compute arc length. Okay, so that's it as far as arc length goes, and that wraps up chapter 7. So this is going to be the end of what's going to be on your chapter 7 exam. Okay, have a great rest of your day, guys.